All right, team, we've done some examples with the radical equations. The idea now is that we're going to do some more complicated problems that are in real applicable situations. So these are when you're going to actually have to use some of the math we've discovered in your career field. So all these examples I'm going to go over. Stay tuned and let's dive on in. The radius of a circle on a coordinate grid that is centered at the origin R can be calculated by this equation. So it wants you to determine the x-coordinate of a point. So we need to determine the x-coordinate. We need to find the x where is this in the spot of the 6? It's in the y value. And it has a radius of 8. R is for radius. So I'm going to go ahead and substitute the information given. 8 is going to equal the square root of x squared plus 6 squared. I'm going to clean that up. 8 is going to be equal to the square root of x squared plus 6 times 6 is 36. Now I'm at a point where I can just solve this. Well, the radical's by itself. So what I'm going to go ahead and do is I'm going to raise both of them to the same power. I'm going to have 8 is equal to square root of x squared plus 36. Raise this to the second power. Raise this to the second power. This is going to result in 64 being equal to x squared plus 36. I need to get my x term by itself, so I'm going to use the inverse of adding 36 and subtracting 36. 64 minus 36 is going to be 28 equals x squared. To get x squared by itself, I need to now take the square root of both sides. And this is going to result in the square root of 28 equals x. So, determine the x-coordinate of the point. X-coordinate of this point is equal to the square root of 28. Let's make sure that this is valid. So I'm going to go ahead and plug in the square root of 28 for x. So 8 is going to equal to the square root of x squared. The square root of 28 squared plus 6 squared. 8 is going to be equal to the square root. This is just going to be 28 because the radical and the power cancel each other out. And we already know 6 squared is 36. When I add these two together, it makes 64. And the square root of 8 is also 8 or negative 8. So this is good. So my x value is equal to the square root of 28. You can also simplify this if you want as well. I can represent the square root of 28. I can represent it as the square root of 4 times the square root of 7. Then it's going to give me 2 times the square root of 7. That works as well. Either answer would be good. So, for these word problems, the idea is that you look at the equation, you substitute the information, and the idea is that you want to isolate the variable you are looking for. Number 2, Melissa deposited $2,580 in an account 3 years ago. the interest is compounded once a year in this equation, where A is the current balance, can be used to calculate the interest rate. If the interest rate is 3.5%, how much does Melissa currently have in her account? Remember, round your answers to the nearest cent. And you also have to make sure you write the interest rate as its decimal equivalent before substituting it into the equation. So A is the current balance, R is the interest rate. I need to turn the interest rate into a regular decimal. A percentage is out of 100, so I need to move the decimal 2 spots over. So it's going to actually be 2 spots over, 1, 2. Fill the gap with a 0. I'm going to be using 0.35 because that is the same thing as the percentage 3.5. So I'm going to go ahead and substitute this in. 0.035 is equal to the cube root of A over 2,580 minus 1. So I'm going to go ahead and get the radical by itself. I see the minus 1 is on the outside, so I'm going to add 1 to both parts. This is going to have 1.035 being equal to the cube root of A over 2,580. Now that I have the radical by itself, I can raise both sides to the third power. So it's going to be 1.035 to the third power. I'm going to raise this guy to the third power. It's going to be A over 2,580. This is going to lead me to have 1.035 to the third power being equal to A over 2,580. My final step is to get rid of the denominator. To get rid of the denominator, I'm going to multiply both sides by said denominator. So I know my answer is going to be the result of this expression. A is by itself. So I'm going to go ahead, plug it into my calculator. I'm going to do the exponent first. 1.035 times 1.035 times 1.035. Then I'm going to multiply it by 2,580. And I'm going to end up with 2,860.49211 equals A. I need it to be money, right? So 49 cents. This is going to be, the A value is going to be equal to 2,860 and 49 cents. Even if there's decimals involved, notice how I applied the same principles. Number 3. The speed in meters per second of a tsunami can be determined by using the formula S equals the square root of 9.8 times D, where D is the depth of the ocean in meters. Suppose a tsunami is traveling at a speed of 8,300 meters per second. How deep is the ocean? Well, the speed is 8,300, right? So S is going to be 8300 equals the square root of 9.8d. Well, I see square root. I'm going to raise both powers to the second. So this is going to lead me to have 8,300 squared equals 9.8d. You might notice that I haven't expanded that yet. That's because I'm going to save it for the end because it's such a large number. I'm going to divide it by 9.8. I'm going to divide it by 9.8. And the idea is that when I use a calculator, 8,300 squared divided by 9.8, this is going to result in the depth at that point. So 8,300 times 8,300 divided by 9.8 is going to result in the following. D is going to be equal to 7,029,591.83. Okay, number 4. The relationship between a radius of a sphere and its surface area is given by the equation r is equal to the square root of s times a divided by 4 pi. R represents radius and SA represents the surface area. Calculate the surface area of a sphere with a 4-foot radius. Okay, a 4-foot radius. Use 3.14 for pi, and I'm trying to find SA. So my equation is going to be 4 equals the square root of surface area divided by 4 times 3.14. Well, I know that 4 is going to be equal to the square root of the surface area divided by, if I multiply 4 times 3.14, that is going to be 12.56. At this point, I can go ahead and take 4, and I can take the square root of my surface area divided by 12.56. And since it's to the square root, I'm going to square both sides. This is going to result in 16 equals surface area divided by 12.56. In order to get rid of this decimal, what I need to do is get rid of the fraction by multiplying by the denominator. I'm going to multiply this by 12.56, and I'm going to multiply this guy by 12.56. This is going to go ahead and result in my answer, 200.96 is equal to my surface area. Number 5. The relationship between the side length of the base and the height of a pyramid cut out of a cube is S is equal to the cube root of 3v, where S represents the length of a side of the base and v represents volume. Calculate the volume of a pyramid with a side length of 4.2 a side length of 4.2. S represents the length of a side. S is going to be 4.2, being equal to the cube root of 3v. I see my radical by itself, so I'm going to raise each side to the index. This is going to lead me to have 4.2 to the third power, whatever that is, being equal to 3v. To get v by itself, I have to divide by 3, leaving me with my answer, 4.2 to the third divided by 3 is going to be equal to the volume. 4.2 times 4.2 times 4.2. And then you divide it by 3. And this is going to give you the following, 24.696 is the volume. The distance between any 2 points on a coordinate grid D can be calculated by using the equation D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, where x1 and y1 represents the coordinates of one point and x2, y2 represent the coordinates of the other point. Identify the points on the y-axis, 0, y, that are exactly 5 units from the point, -3, -4. So it wants us to find all of the points that are on the y-axis at this point, 0, y, that are exactly 5 units away from the point, -3, -4. I'm going to let this x to be x1, this y to be y1. I'm going to have this guy be x2. I'm going to have this one be y2. The distance is exactly 5 units. Let's go ahead and figure this out. 5 is going to be equal to the square root of x2. x2 is -3 minus x1, 0, squared plus y2 is -4 minus y1 is just y squared.